Good day, class. We'll be looking at the transformation of graphs. As you would know, the word transformation comes from the verb to transform, and to transform means to change. So essentially, we'll be looking at how graphs change when we make certain changes to its matching function. Today we'll be looking at the translation of graphs, specifically the vertical translation of graphs. Okay. Now here we have the parent function f of x is equal to x squared. That is our parent function. Okay. Now I'm going to show you what happens if I add a number or a positive number to this function. Our parent function is f of x is equal to x squared. Okay, so we're going to add a positive number to our function x squared. Okay, so let's see what will happen. So f of x is equal to x squared, and I'm going to add 3 to my function. Notice that we have a new graph. We have a new graph that is 3 units. So we have a new graph. This is our new graph right here. Yes, which is 3 units away from the origin in the upward direction. Okay, in the upward direction. All right. Now, this graph in red is the graph that we started with. That is the graph of f of x is equal to x squared. That is our original graph. Okay. The graph in green, that is our new graph. That's our new graph, which is represented by f of x is equal to x squared plus 3. I'm going to introduce you to a new word, because this graph is the original graph, the graph that we started with. This graph is our parent graph. Parent graph. Yes? All right. Now, how we got the green graph, our new graph. Yes, we took the parent graph and shifted that graph 3 units upwards to get our new graph. Okay, so in mathematical language we would say that our parent graph was shifted or translated 3 units upwards. Okay, so f of x is equal to x squared plus 3 is saying to us that the original function, the graph of the original function, which is x squared, has been shifted 3 units upwards. Okay, all right, let us look at a different example. So I'm going to type another parent function. I'm going to use the absolute value function. Alright, here we have our parent graph for the absolute value function. Alright, now I'm gonna add positive 1 to my parent function, which is the absolute value of x. Okay, so f of x is equal to the absolute value of x, and I'm going to add 1. Okay, so as you can see, the red graph is our new graph. The black graph is our parent graph. That is our original graph. Alright? Our red graph is coming from the parent graph. Yes? In the real world, the parent comes before the child. Yes? Chronologically speaking, the parent comes before the child. Alright? So the black graph is the parent graph, and the red graph is coming from the parent graph. Alright? Now, to get this red graph, the parent graph was shifted 1 unit upwards to get our new graph. And we say in mathematical terms, the parent graph was translated 1 unit upwards. Okay, or it was shifted 1 unit upwards, or 1 unit up. Okay, or it was shifted up by 1 unit. All right, let me look at another example. Let me change let me use g of x. G of x is equal to, so this is parent function for the family of cubic functions. So this is our parent cubic function. Now I am going to add 2, positive 2, to the parent function. Okay. So my original function is x cubed, and I'm going to add 2 to my original function. Thus 2. Alright. As you can see, the parent graph was shifted 2 units upwards to give us our new graph, which is in red. Okay, so g of x is equal to x cubed plus 2 is telling us that the original function, the parent function, which is g of x is x cubed, was shifted 2 units upwards. So you can know what changes were made to the parent graph or the original graph just by looking at this function right here. Okay. Alright, please look out for my next video, which will be another case of the transformation of a graph or a translation of a graph. Alright. And before I continue, before I end this video, I should say, notice that the change that took place vertically. It took place vertically, yes, in a vertical direction. All right, in a vertical direction. All right. And I want to say this. You will hear this repeat. You will hear me repeating this in future videos. Whenever we apply anything to the outside of a function, is going to lead to a vertical change. Alright, this will make more sense to you in future videos. Okay, have a good day.